Good morning, everyone. Happy Friday. Welcome to TVE Happy Math Hour, our weekly interactive math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. Thank you. So now, at this time, please mute your mics for the best sound experience, otherwise the feedback could interfere with information we will be sharing. We'll be sending the 1324 room link on the chat so that you may connect to your session if you're here for Math 1324. Ms. Patricia will be sending individual messages to everyone to gather your student ID numbers to sign you in. Without further ado, I'll pass it on to our presenter so that we may begin.
Hello, everyone. So again, if you are here for 1324, then you can click the link. Otherwise, we are going to go ahead and talk about inverses of matrices and determinants of matrices. So these are the last sections of chapter 8. And if we have time, then I can also show you how to use the calculator for some of these. Okay. So basically in this section, we talk about an inverse of a square matrix. So in order to have an inverse, it does have to be a square matrix. And so if you take the matrix and you multiply it times its inverse, it's going to equal the identity matrix. But in order for it to really be inverses of each other, we should be able to multiply the inverse times the A should also give you the identity. The symbol that we use for inverse is the power of -1. And so we say that this is A inverse. This identity matrix is a 2 by 2 identity matrix is the matrix that has ones all the way in the diagonal and zeros everywhere else. So a 3 by 3 identity matrix would have ones on the diagonal and zeros everywhere else. Okay. So let's look at an example. So it says show that B is the inverse of A. So in order to show that they're inverses, we need to make sure that if we multiply them together, A times B, that it's going to give us the identity matrix, but also that B times A is the identity matrix. So we'll multiply these. And as a review for the multiplication, we can decide if we can multiply by looking at the order first. So these are both 2 by 2 matrices. So let me just go ahead and write something here. So this is a 2 by 2, and this is a 2 by 2. So if these numbers on the inside are the same, in other words, the number of columns of the first matrix is equal to the number of rows, then we can multiply. And to multiply, we're going to take the first row times the first column. So we would multiply -1 times 1 is -1, and 2 times 1 is +2. So if we add that together, we'll add them here in a second. It's going to give us a 1. But then we go to the next column. So -1 times -2 is +2. And 2 times -1 is -2. Since I don't have any more columns, then we can go to the next row. So -1 times 1 is -1. And 1 times 1 is +1. And now we go to the next column. -1 times -2 is +2. And 1 times -1 is -1. So we simplify here. We have -1 plus 2 is 1. 2 minus 2 is 0. -1 plus 1 is 0. And 2 minus 1 is 1. So A times B does give us the identity matrix. But it's not good enough for us to say that they are inverses until we multiply B times A. So if we multiply B times A and we follow the same steps that I showed earlier, then we also get the identity matrix. So since A times B is the identity matrix, B times A is the identity matrix, then we can say that A and B are inverses of each other. So B is the inverse of A. Now to find the inverse is actually what this section is all about. if we want to find the inverse, there is 3 different ways that you can do that. And I guess you could say maybe 4 if you use a calculator, but um, by pencil and paper, there's 3 ways. We're going to focus today on this method here that I'm kind of circling my mouse around, and then I'll give an example of the first one. The third one, I encourage you to look at it. You can find it in your textbook. This third method is really good for those of you that felt very comfortable with this chapter 7 methods, the solving systems of equations. Okay, so we'll go to the first method. So in this method, they want you to take A, which is your matrix, and we're going to attach the identity matrix. So if we want to find the inverse of this matrix, here's my A, and then I put the identity matrix. So then we're going to use row operations, and these are from section 8.1. And our goal is that when we're finished, on the left side, we're going to have the identity matrix, and whatever's left on the right side is going to be your inverse. Okay. Now, the good thing is that if you're working with 2 by 2 matrices, the second method is going to be a lot quicker, as you'll be able to see in a few minutes. Okay, so now this process here is what we did in section 8.1. So your goal is to make sure that this number here is a 1, and it's already a 1, so we don't have to do anything. So now my goal is to make anything below it a 0. So since I want to make this a 0, if I add 1 plus -1, then I get 0. And so I can represent that by saying I'm going to add row 1 plus row 2, and whatever answer I get, I'm going to place it back in row 2, since that is the row that I'm trying to change. So for row 1, I just copy it down because we're not going to change it. And then now we can add, so 1 plus -1 is 0. 4 plus -3 is 1. 1 plus 0 is 1. 0 plus 1 is 1. And so now notice we have our 1 here, and we have the 0. And this is the order that that I recommend my students to work on, because if they try to change the 4 first, then it might change the other numbers again, and then you'll be working in circles. So I always start with the diagonals first, make them a 1, but once you make this a 1, make everything below it a 0. So now let's look at the second diagonal, which is this number here. I need it to be a 1, which it is, so that's good. So now anything below it or above it, I need it to be 0. So since I have a 4, if I had a -4 in place of my 1 and I added to 4, I would get a 0. So what we're going to multiply or do is we're going to multiply -4 times the row 2 so that we can get a -4 here. Then we're going to add it to row 1. But whatever answer we get, we want to put it back in row 1. So that means that row 2, we're not going to change. We're just going to use it. And so if you notice here, I have my row 2. I didn't change it at all. And so now if I multiply, -4 times 0 is 0, plus 1 is 1. So that goes right here. -4 times 1 is -4, plus 4, 0. -4 times 1 is -4, plus 1 is -3. And -4 times 1 is -4, plus 0 is -4. So as you can see, now we have the identity matrix on the left side. And so whatever's left on the right is going to be your inverse. So we can write it as A inverse is equal to -3, -4, 1, and 1. Okay, so this method is a little bit longer than the method I'm about to show you. But for some of us, we are comfortable with using Gauss-Jordan elimination to rewrite our matrices. Okay, so the formula. The formula only works if you have a 2 by 2. If you have anything bigger than 2 by 2, then you would have to use this process here. Okay. So the way it works is if they give you a matrix A, B, C, D, then to find the inverse, we can take 1 divided by AD minus BC, And then in the matrix, we're going to switch the A and the D. And then we're going to switch the signs for B and C. Okay. So if we want to find the inverse of this matrix, then, and then just one more point. This bottom number is called the determinant, which we'll talk about in a few slides down the road. Okay. So here's my A, B, C, D. I'm trying to find the inverse, so I always like to write down the formula, and then I work below the formula. So we're going to have 1. A is 1. D is -3. B is 4. And C is -1. And then I switch my A and D. So here I had 1 and -3. Now I have -3 and 1. I'm going to switch the signs for B, which is -4. And the sign for C, if I switch it, is 1. So we simplify, we get -3 plus 4. And then we get 1 over 1, which is 1. And so 1 times each of these elements in here is going to be themselves. So our final answer is the inverse is -3, -4, 1, and 1. If you had a number here like 4, then you would have to multiply 4 times -3, 4 times -4, 4 times 1, and 4 times 1. Okay, but since it's a 1, then it's just going to be itself. So as you can see, this method is a little bit quicker than the other methods. But the problem with it is that it's only works for a 2x2. Let's go to the next page. Okay, so it says use any method to find the inverse. So I believe I'm going to use the formula method. And so here's the formula. So the first one, we would have A times D, so that's 3 times 2. So that goes here. And then B times C would be -1 times -2. Then we're going to switch the 3 and the 2, so I get 2, 3. And then we're going to switch the signs for -1 and -2. So we get 1 and 2. If we simplify, we get 3 times 2 is 6. -1 times -2 is +2. 6 minus 2 is 4, so we have 1/4. And so we need to multiply that scalar. So 1/4 times 2 is 2/4. 1/4 times 1 is 1/4. 2/4 times 2 is 2/4. And 1/4 times 3 is 3/4. So we reduce, 2/4 is the same as a half, and 2/4 is the same as a half. So this is going to be our inverse. Okay. So for letter B, we have 3, -1, -6, and 2. So if I use the formula again, I'm going to have 1 divided by A times D. So that's 3 times 2. And then C and B is -1 and -6. -1, -6. So now for the numbers that go in the matrix, we're going to switch the 3 and the 2. So that becomes 2 and 3. And then the signs for B and C, we're going to switch them. So we get 1 and 6. If we simplify, we get 1 divided by 6 minus 6. 6 minus 6 is 0. And 1 divided by 0 is undefined. So we cannot divide by 0. If that happens, that you get a 0 in the denominator here, then we say that A is not invertible. And what that means is that it does not have an inverse. Okay, so not everything will have an inverse. Now let me just share my screen really quick. I want to show you how you would put this in your calculator in case your instructor lets you use a calculator. Okay, so if you have a graphing calculator, then we would turn it on. Let me turn it on here. And so you would press second matrix. You go to math. Oh, you go to edit. So I'm going to click A. And then it asks you to enter the order. So this was a 2 by 2. And since I don't remember the numbers, I'm just going to enter whatever numbers that come to mind. and 7. Okay, so once you have your matrix in here, then you second quit. And to find the inverse, you're just going to go second matrix. You're going to select A, and it brings it over here. So the key for inverse is this one here, x to the power of -1. We press enter. And if you notice here, it has decimals, so you can't see the rest of it. To get rid of all these decimals, you can just press, Ms. Salazar, you have a question?
Miss Chuka, I don't think we can see your
You can't see
calculator.
the calculator? Okay, let
No,
me
ma'am.
try again. Thank you for letting me know. All
Sorry
right,
about
let's try
that.
that again. No, it's good. I'm glad you told me. So let me see. Can you see it there?
I
Oops.
don't see anything on the screen.
Okay, let me try one more time. Oh, I was only sharing my window, so. Okay, let's try this again. I think
Oh,
you
there
could
we
see
go.
it now, right?
Yes, we can.
Okay, so
Okay, thank you.
let me start again. All right, so what you want to do is, let me see. Can you still see it?
Yes, we can.
Okay, so what you want to do here is go second matrix, and then you can edit. I'm going to go to B, and it's asking for the order. So we were working with a 2 by 2. So I entered 2 by 2, and then I'm going to just put whatever number in here because I don't remember what we were working on. So once you have that information, just second quit. And if you call the matrix, and I'll still pick A since that's the one I was showing you earlier, and the inverse key is going to be this one here. Okay, so when you press enter, the inverse has all these decimals, but you can't really see them over here. So you can scroll, or you can just press math and click number 1 where it says FRAC. That means that you want your answer as a fraction. And so then you would see your inverse. So 7 73rds, -8 over 73, and so on. Okay. If you can use the calculator, then you can also multiply. You can go A times B, and then you press enter. Okay. Or you can add them the same way. You would bring them out. Just use plus sign here. And then in a little bit, we're going to talk about the determinant. So to do the determinant, you go to math right here. You go to 1, and then you call the matrix. And you press enter, and it'll give you that determinant, which we'll talk about here in a second. And then the last one that I want to show you is, let me make this a 2 by 3, and hopefully the numbers I pick will have solutions. Okay, so if you wanted to solve this system, then you can also go to matrix. You would go to math, and if you scroll down, you're going to see letter B here, RREF. That means reduce row echelon form, which is the Gauss-Jordan method. And if I bring it back, and I'm going to press fraction. Then what this tells you here, notice your identity matrix is here, and then it gives you the solution. So x is equal to -20 over 73, and y is equal to 54 over 73. Okay, so in a little bit, we can talk about this in more detail. Let me go back to the presentation. Let's see. I think we were right. And let me just go to where we were at. Okay, so we did these two examples of finding the inverse. But now what we want to do is, well, why do we even need the inverse, right? Like, what's the point of the inverse? So for this one here, I guess, let me go ahead and just review this before I tell you the point of the inverse. Since this is a 3x3 matrix, so it's really big, the formula doesn't work here. So if you are able to use a calculator, then you can put that in the calculator. If you're not able to use a calculator or don't have a graphing calculator, then you would need to follow the steps that we did earlier, where you put the matrix here, you attach the identity matrix, and then you do the rows, the row operations, so that after you do all the row operations, then you're going to have your diagonals here are ones, and whatever's on the right side is your inverse. Okay, so that would be the same process. And if you okay, so that would be the same process. If you don't have a graphing calculator, you can also use decimals. They let you input it in matrices as well. Okay, so why do we need the inverse? So in chapter 7, you looked at different methods of solving the systems of linear equations. We had substitution method, we had the addition method. And then in chapter 8, you also learn how to use the Gauss-Jordan elimination to solve the system. So now this is just another way to solve the system. So here, if we're trying to solve for x, which x is basically your x and y, then if you take the inverse and multiply it times b, it's going to give you your answer. But I'll explain what b is here in a second. Okay, so it says here, use the inverse to solve the system of linear equations. So this is the inverse. They already gave it to us, so we don't have to find it. But whenever you have a system, then we can make up some things here. So the matrix A is going to be the coefficients. So in this example, x is 1, y is -3, x is 3, and y is -8. So this is your coefficient matrix. And the first step you want to do is take the inverse of this matrix. And I already did that here. So if you take the inverse of this matrix, it's going to be this one here. Okay. And then your matrix B is going to be your constants. So 4 and 12. So that's your constants. And then the matrix X is just your variables, X and Y. Okay, so to solve this system, we use this formula here. So it has the matrix X, which is X and Y, A inverse, which were given. So I'm just going to write it here. And then B is your constant matrix, 4 and 12. So to get your answer, we would multiply -8 times 4, 3 times 12, add those numbers, and we get 4. And then -3 times 4 is -12. 1 times 12 is 12. -12 plus 12 is 0. So my solution here is x is equal to 4 and y is equal to 0. Okay, so again, the steps here are, if they don't give you this inverse, then from your system of equations, you have to create your matrix A. Again, it's made up of all coefficients. Your matrix B, which is your constants, and then X, which is just your variables, X and Y. Then you find the inverse of A and multiply it times B. And then that would give you your solution. Okay, so let's try this one. So again, first thing is find A. So A is 1, -5, 5, and -24. B is 27 and 128. And then X, well, I'm using my variable X and Y, so I get X and Y. I don't have an inverse, so I need to find the inverse. So to find the inverse, I use the formula because A is a 2 by 2. So I would have 1 divided by A, which is 1, times D, which is -24, minus B, -5, times C, which is 5. And then for the matrix itself, we're going to switch the 1 and the negative 24. So we get negative 24 and 1. Then we're going to switch the signs. So negative 5 becomes 5 and 5 becomes negative 5. If we simplify, we get negative 24 minus negative 25. And then we simplify again. So we get negative negative is positive. So that's going to be 1 divided by 1. And 1 times this matrix will be itself. So that is our inverse. So now we take our inverse. So I wrote it here. Times our B matrix, which is 27 and 128. And we're going to multiply. So negative 24 times 27, it's right here, plus 5 times 128. And negative 5 times 27 plus 1 times 128. If we simplify, then we get negative 648 plus 640, which is negative 8, and negative 135 plus 128, which is negative 7. So my solutions are, let me go back, x equals negative 8 and y equals negative 7. So for my classes, especially if it's a paper test, I do want my students to write the solution as follows, as an ordered set. Okay, so in a WebAssign, if you're doing the homeworks, then that just depends on what form they're asking you to input your answer. Okay, so let's go on to another example. It says use the inverse matrix to solve the system. So they give you the inverse, so that's good. We don't have to find it. We still need A, so again, A is just your coefficients. So we have 1, 1, 1, 3, 5, 4, 3, 6, 5. Your B matrix is the constant 0, 6, and 3. 0, 6, and 3. And then X is going to be your X, Y, and Z. So if we set this up, we have A inverse, which was given to us, times 0, 6, and 3. So we're going to multiply 1 times 0 and 1 times 6 and negative 1 times 3. Okay, so let me see if I show the work. No, okay, I don't. No, okay, I don't. So let's go ahead and do that. So 1 times 0 is 0. 1 times 6 is 6. Negative 1 times 3 is 3. So 6 plus 3 is 3. Then we go to the next one. So negative 3 times 0 is 0. 2 times 6 is 12. Negative 1 times 3 is negative 3. So 12 plus negative 3 is 9. And then 3 times 0 is 0. Negative 3 times 6 is negative 18. And 2 times 3 is 6. So 6 plus negative 18 is negative 12. So my solution is x is equal to 3 and y is equal to 9 and z is equal to negative 12.
I can't do it. Tell me.
Okay, so let's go to the next slide. So now we're going to look at the determinants, and I kind of mentioned that word earlier. So the determinant of a matrix is always going to be a number, okay? And so here, the way we find it for a 2 by 2 is we multiply A1 times B2, B1 times A2, and then that's going to be your determinant. The way we know we're looking for the determinant is instead of brackets, we make these vertical lines, okay? So let's look at an example. Find the determinant. So for A, if I want to find the determinant of A, instead of my brackets, I change it to vertical lines. And then I'm going to multiply 2 times 2 and negative 3 times 1. So 2 times 2 and negative 3 times 1. So 2 times 2 is 4. Negative 1 times negative 3 is positive 3. And then we get 7. So my determinant is going to be 7. And then for B, we would multiply again. 2 times 2. 2 times 2. And then negative 4 times 1. So we get 4 minus 4 is equal to 0. Okay, so go ahead and try letter C. I'll give you a couple of seconds to try it. Okay, so let's check to see what we get. All right, so we go 0 times 4. It's right here. And 2 times 3 halves. And so 0 times 4 is 0. 2 times 3 halves, the 2's become 1. So 1 times 3 is 3. And 0 minus 3 is negative 3. In a little bit, I'll show you how to find the determinant of a 3 by 3. Okay. But first, how can we use this determinant to solve a system? So if you notice, you've been learning different ways to solve a system. And so what I tell my students is I show you all the ways, and then if I'm giving you a test, I'll just say solve the system, and you decide which method you prefer. Okay. So here we have Kramer's rule. And so Kramer's rule is using the determinants. So in order to use Kramer's rule, you're going to need to have a coefficient matrix, which is made up of A1, B1, A2, B2. We're going to find the determinant of this coefficient matrix. And then we're going to find dx. And to find dx, notice that the coefficients of x were replaced by the constant, C1 and C2. Okay, so we have the constants and then the y coefficients. In dy, we replace the y coefficients with the constants, and then we leave the x coefficients. Okay, once you find the determinant for these three things, then we can say that x is going to be equal to the determinant of the dx divided by the d, and y is going to be dy divided by d. Okay, so that is the setup. So let's try an example. And notice it says if possible. Okay, so here we have our coefficient matrix, or I just wrote down the formula. Okay, so we have the formula. So our coefficient matrix here is going to be 4, negative 2, 3, and negative 5. And then let's set up our next one, for the determinant. So the determinant is going to be 4 times 5, or negative 5, and negative 2 times 3. So 4 times negative 5 is negative 20, minus negative 6. And so we get here negative 20 and minus 6, so negative 14. And now let's do dx. Okay, so for dx, we're going to have the constants, which are 10 and 11, and then the coefficients of y, which are negative 2 and negative 5. If we find the determinant, 10 times negative 5, negative 2 times 11, so we get negative 50 minus negative 22, and then 50 plus 22 is negative 28. Give me a second, I need to sneeze really quick. Hold on. Okay, and I can never sneeze one time. It always has to be like 3 or 4 together at the same time. Okay, so now let's look at dy. So dy, we replace the coefficients of y with our constants. So we get 10 and 11, and then the coefficients of x are 4 and 3. So 4 times 11 is 44, and then 10 times 3 is 30. So if we multiply, 4 times 11 is 44, and 10 times 3 is 30. So if we subtract, we get 14. So now that we have our three determinants, we can use the following formula. So x is going to be dx divided by d, and y is going to be dy divided by d. So dx is 28, d is negative 14, so that gives us a 2. And then dy is, where's my dy? 14. And then d is negative 14, so we get negative 1. So my solution is going to be 2 for x and negative 1 for y. Okay, so that is using the determinant to find the solution to the system. So now I'm going to go ahead and show you how to find the determinant of a 3 by 3 matrix without a calculator. So with the calculator, you would enter this in the calculator and then press the math key and do the DET to get the determinant. But without a calculator, first we're going to find something called the minors and cofactors of A. Okay, so basically what you want to do is you're going to cross out the first row and the first column. And if you notice, it creates a little 2 by 2 matrix, right? So negative 1, 2, 0, and 1. So then we find the determinant of this. And so that's going to be negative 1. And then you continue the process. So now I'm going to cancel out this row and this column. And again, you can see our little 2 by 2 matrix being formed. So if we find the determinant, we get 3 times 1 is 3, minus 4 times 2 is 8. So that gives us a negative 5. And then we keep going. Right? So the next one will be this row and this column. And then we see the 2 by 2 matrix. So 3 times 0 is 0. 4 times negative 1 is negative 4. And so we get negative is 4. Okay. And so it looks like we're finished, but we still have, to consider the second row now. So we do the same thing. Second row, first column, we can see that 2 by 2 matrix here. So 2 times 1 is 2, minus 0 is 0. And then if we subtract them, we get 2. So now we go to the next one, cross out that second column, second row. So we get 0, 1, 4, and 1. So 0 times 1 is 0. 4 times 1 is 4. So we end up with negative 4. And then we keep going. And we keep the same process. The last one is to do the bottom row as well, the third row. And if you do the third row with each column, then we're going to have all these different solutions, which we got from here. Negative 1, negative 5, 4, 2, negative 4, negative 8, and so on. The last one would produce these here. So once you get that, then we go to the next one. We go to the next one. So what you want to do is we're going to be looking at these cofactors. Give me a second. We're going to be looking at the cofactors. So these signs that are in here are going to be important because we're going to multiply these results with these signs here. Okay, so let me show you how. So if you look at this, we have negative 1 times a positive is going to be negative 1. Go to the next one. Negative 5 times a negative will be a positive 5. And then 4 times a positive would be 4. 2 times a negative would be negative 2. And then so on. Negative 4 times a positive, negative 4. Or let me see where, negative 4. Negative 8 times a negative is a positive 8. 5 times a positive is 5. Negative 3 times negative is positive. and -6 times a positive is -6. So so thank God for technology, right? Because with technology, it's just a lot easier. So now the determinant of the sum of the entries is going to be as follows. We're going to take the following. And the good thing is this will work for whatever row you're looking at. Give me a sec, quick scan. So if we look at this one here, we have 0. So 0 times -1, 2 times 5, 1 times 4. And if I multiply these out, I get 0, 10, and 4, and I get 14. But you could also do the other row, 3 times -2, -1 times -4, 2 times 8. And if you do the math here, you still get 14. And the same with the last row, you still get 14. So the determinant of this 3 by 3 matrix is going to be 14. Okay, so that's how you would work this matrix using without the calculator. Okay, so basically that is it for section 8. I believe it's 8.4 and 8.5. Okay, so if you have any questions, let us know. And then I believe next week is our last session for the semester, which would just be a review for the final, but I'll pass it over so they can display that information for you.
Thank you, Ms. Chuka. Yes, so if you would like to download a copy of the presentation, you can go to the top right corner and click on the box with the arrow going down while the presentation is on the screen. We do want to remind all of you about the previously recorded sessions, which are available on our YouTube playlist. This session will also be available on that playlist later today. Also linked was a short survey to help us improve our TBE sessions. Please take a few minutes to fill out that survey and remember to send your student ID number to us before you log out. Before you all leave, I want to share the TBE sessions that we will have next. At 1 p.m. today, we will have a presentation by Service Learning. Join us again next week at 11 a.m. for final exam reviews, which will be our last Happy Math Hour for the semester. That 1 p.m. session will be a presentation of summer camps for kids and library resources. Thank you all for coming in today. We hope you all have a lovely weekend. And if you have any questions, feel free to use the chat box or your mic. We hope to see everyone again for Happy Math Hour.